See, in this question again we need to calculate I of t. Again we have to follow that same equation, that is I of t would be equal to I of infinity plus I of 0 minus I of infinity e raised to power minus t by tau, right? Again remember I told you for step 1 at t equal to 0 minus, then step 2 and then step 3. You have to follow simple these steps. Okay, so first of all we'll draw at t step number 1 at t equal to 0 minus, that is the steady state condition, and in the steady state condition the inductor will behave as a open short circuit. Now tell me, at t equal to 0 minus, switch will be opened or closed? Yeah, switch is going to be closed and inductor will behave as a short circuit, and we have to calculate the current across inductor, right? So simple. There are how many meshes? 3 meshes. This we can consider I1. See, they have mentioned the direction of current here now, like that, so we should also take current in that direction only, like that. Okay, they have mentioned the current flowing across inductor in this direction, so we can consider the same direction. It would be better for us. Now we tell me the all the 3 equations. Minus 5 I1 is equal to 0, so we can say I1 is equal to 0. Then second equation, yeah, so simply we can solve it all the 3 equation, and we want which value, I1, I2 or I3? Tell me. I'm asking, we want current across inductor, and current across inductor would be equal to I1, I2 or I3? No, no. This time inductor is in the corner wall, right? And in the corner wall there is a flow of single current or double current. So inductor across current would be equal to, it is in which room? Inductor is in which room? In the room of I1, in the room of I2, or in the room of I? So inductor current would be equal to I2 only, right? So we can conclude it, I3 is 3 ampere, so I2 would be also 3 ampere. Got it? We got the first value, that is I0 as 3 ampere. In the next step, step number 2, we have to calculate at t equal to infinity. Again, that was the steady state condition, right? Now for this, switch is opened or closed? So it's open, and again inductor will behave as a short circuit, so we have to calculate the current across inductor. Now simply how many meshes would be there in this case? 2. So this one we can consider as I2, and this one we can consider it as I1. Now tell me the 2 mesh equation. Minus 5 I2 minus 10 I2 minus I1 would be equal to 0. Tell me the second mesh equation. So we can simply solve it, and then we'll get the value of I2 also. Then we'll get it as 2 ampere. Okay, now we got this one also, that is 2 plus, right? Now what is left? Tau. So step number 3, what was the step number 3? We have to calculate, that was the transient condition, right? Now for R equivalent at t equal to 0, switch is opened or closed? Open, right? And for this step, in if there is a current source will behave as a open circuit. Remember, if there is a voltage source, so for calculation of R equivalent, that R equivalent voltage source must be short circuit, and if there is a current source, that must be open circuit, right? And again we have to remove inductor. We have to mark here A and B, right? We have to calculate R equivalent, that would be across A and B. Now only two resistor is left, right? One is 5 ohm, another one is, so these two resistor are in series or in parallel? Yes, so R equivalent is 5 plus 10, it is in series. We need to calculate tau. Tau is L by R. L value was how much? 1.5 Henry. So 1.5 divided by 15. Tau is how much? 1 by 10. That is 0.1 second. Got it? We can put it here. Tau is 0.1 second. So if we'll solve it, we'll get I of t would be equal to 2 plus 3 minus 2 is 1, e raised to power minus t by 0.1 is minus 10 t second, right? So this is our final answer for this. Now if we want to draw the graph also related to this, the x-axis time and the y-axis is the current, that is initial minus final. So this is the final value, right? This is the initial value. Initial value we got it how much? 3 ampere. So start from the 3, and final value how much we got it? 2 ampere. So it ends at 2, and it is exponentially decreasing, right? Because there is a negative sign, so the graph would be like this. It starts from 3 and it ends at 2. Okay, so this is the graph for current. Got it?